Good morning, guys. Welcome to GoOnlineTrainings.com. Yesterday, we were able to understand the need for the Azure Data Bricks and what is the prerequisite if you wanted to understand uh, data bricks or data factory. So in the data engineering course, you will have two modules. Data factory will be the ETL software, cloud software, which is similar to your SSIS or your Informatica. So those are on-premises ETL softwares. And it is similar to that Azure Data Factory 30 hours course. The prerequisite, as I mentioned earlier in the yesterday's class, you need to know SQL basics so that you will be able to understand Azure Data Factory. But if you wanted to get into Azure Data Bricks, it will be taking SQL as a prerequisite and Python also. At least basic Python you need to know so that you will be able to start with the Azure Data Bricks. So in that, we are going to be completely focusing on the big data concepts, right? Yesterday, I was talking about what is a big data, what is a Hadoop, what is a Spark, everything I was talking about. People who missed yesterday's class, I strongly recommend that you need to go through the demo without fail so that you will be able to understand today's class as well. So independently, you can learn Azure Databricks first, or you can learn ADF later, or you can learn ADF first, or you can learn Databricks later. Anything you can start first, anything you can start later. So for the ADF, only SQL is required. For the ADB, we need to learn Python plus Spark language also we will be able to discuss, but it is not very complicated language, very easy. And Python is also not complete in-depth of Python is needed. Some 20 days basic Python is needed. So Python, web development of Python is called as a full stack Python that you don't need, that you don't require. And the data science Python, that is also not required, right? Python is available in many forms. So we don't need full stack Python. We don't need data science Python. We need some basic, programming of Python. 20 classes if you learn, that is sufficient. Clear? If you don't know SQL, you can buy the videos from us and you will be able to practice daily one SQL video so that you will be able to, work with the data engineering. So these are the things that I'm going to be covering. So now bricks is going to be going on. And after this, gets over, then I'll start Azure Data Factory. Yeah, am I clear? So you can join for the both courses. You can join for the single course. That is up to you. But if you wanted to become a data engineer, so these are the prerequisites. Any non-IT people, they can get into this. Any age, any graduate, any long gap guys can get into this. Clear, guys? So today, let us start the Azure Data Bricks concept. So let us summarize whatever we discussed yesterday and we'll continue further. If you wanted to get into Azure Data Bricks, we'll be talking about what is a prerequisite. SQL knowledge is required, basic Python is required, and the cloud fundamentals. What is a cloud? And all of them I have discussed in yesterday's class. And we also should know about what is big data, what is Hadoop, what is Spark and Scala, Databricks. All these things been discussed yesterday. And today I'll be talking about the difference between ADF and ADB, Azure Data Factory, Azure Data Bricks. The differences we will be able to talk about it. Who can take this course means any freshers, recent passed outs, IT developers from the different disciplines, on-premises data engineers, database developers, big data developers, BI or ETL developers can learn this course and making a career switch from different functional roles to tech roles. You're a senior sales manager, or if you're a insurance or guy or operational guy, 10 years of completely into pure insurance domain or a banking domain, you wanted to switch a career from those functional roles to the technical roles, means you can learn these kind of a courses very very easily. SQL, you need to buy the videos from us, and very very from basic level to advanced level of SQL is there. You daily watch one SQL video so that you will be able to understand the SQL. Along with that, you can also daily attend the live classes of Azure Data Bricks. Once it is over, you can also attend the live classes of Azure Data Factory. But if you don't have a time, you can also opt for the recordings, right? So you can opt for the recordings, and if you have any doubts or the clarifications, you will be able to call me on this number. I have given my number directly. You will be able to call me on this office number so that I will be able to connect one to one and I can clarify the doubts as well. Clear? So this is my direct number. If you wanted to ask me anything, so lab support I'm going to be giving. You can just give me your issues and everything so that we will be able to connect one to one and we will be able to, give you the proper solutions based on your free time, based on my free time, either in the evening or in the morning. Okay, so morning I'll be busy most of the time, but in my evening times I will be able to connect with you. I will be able to give you my support. So this is my number, direct number. You can just call me anytime for any doubts, clarifications. Chalo guys. Okay, so today let us understand a few more things. uh, Course content also I have given yesterday. So this is the course content for the next 25 hours. Prerequisite is SQL you need to understand, and basic Python also you need to know. So all these things we're going to be covering. Real-time project is included and with ADF and ADB. And so that you will be able to talk about this project in your CV and you can also clear the interviews. Chalo, guys. And so we need to understand when is that I should use ADF, when is that I should use Azure Data Factory. Clear? So these are the two things that we need to understand. Before that, let us recap whatever we discussed yesterday. So yesterday I was talking about cloud fundamentals and I spoken about completely what is ADB. I have spoken yesterday, and what is big data, what is Hadoop, what is Spark and Scala, everything I have given yesterday. But today I'll be talking about ADF versus or ADB. Clear? I'll be talking about it today. ETL. So today's class I'm going to be talking about. This is the second class. This is the first class. Yesterday's class, I spoken about that, right? So today we'll talk about ADF and ADB, Azure Data Factory in this one. And today we'll talk about ETL and ELT, right? And today we'll talk about some Hadoop, big data, Hadoop fundamentals, and that is what you have to know. And we will be able to understand what is a cluster, and let us understand what are the different methodologies we have. So what is a data warehouse versus what is a data lake versus, right? And we are talking about data warehousing and data lake and different Hadoop file systems also we will be able to implement today. So we are going to be concentrating on data warehouse and data lake architecture, and we will be able to talk about a cluster and what is a cluster and what is a data warehouse. All of them we're going to be understanding today. Clear? So that is what is the thing. So as I discussed yesterday, so if you wanted to store the data in the IT industry, that is what the topic yesterday, right? So without data, IT industry is not there. If you wanted to store the data, IT industry is using Excel sheets. When you have a small amount of data, when you have a megabyte of data, I can store my data in the Excel sheets. I'm talking about megabyte of data. But when I'm getting gigabyte of data, for example, Amazon getting every month 500, 600 GB of data, that data IT industry is going to be storing in SQL, nothing but your RDBMS or relational database management systems. Here we are going to be using Oracle software or a Microsoft SQL Server software, right? Or you have a DB2 from IBM. Lot of softwares we are going to be using to store your data. It is going to be storing GBs of data. Now, When you have every month you're getting 500 GB, 500 GB into 12 months of data, it will become 6,000 GBs of data. It is now, it is equivalent to 6 terabytes of data. So I would like to store 10 years of data. It is approximately 60 terabytes of data I wanted to target. I would like to store this kind of a data in normal SQL. You will not be able to store. So this is when we are going to be storing your data into your data warehousing systems. Clear? But what is a data warehouse? I clearly told data warehouse means a large hardware. Inside that, you need to install SQL software. SQL means Oracle, SQL Server, DB2, Netezza. Lot of SQL softwares are available. Any one of the software you will be able to install it so that it can accommodate terabytes of data. Clear? So IT industry started the language, C language started 1960, and after that we have spreadsheets. Everything got implemented. Or Excel, or earlier people were storing the data into the text files. Clear? But 1970, you got to know text files or Excel is not sufficient to store the data. We need to, have proper data storing technologies. There's a company called IBM company and research. They have done the research on the SQL and they have invented SQL and RDBMS technology in 1970. So you're able to store the structured data, means the data which is there in the rows and columns. Right. So from 1960s to 1970, we have SQL. And when you have so much of a data, even normal SQL is going to be failing. In 1990s, IT industry thought that we need to, implement one more system to store large amount of data and large 10 years of data if you wanted to maintain, 20 years of the data if you wanted to maintain. In a single system, I will not be able to maintain. I need to have one more system. That is what is called a data warehousing system. So data warehousing means you have a large, hardware. So yesterday I was talking about I have 1 terabyte of hard disk in my laptop. 4 GB of RAM I have. I have i5 processor I have in my computer. This is my configuration. If I install Oracle, I can store maximum 1 terabyte of data because it is the capacity is 1 terabyte, right? So maximum data I can store only that much. But if I take 1,000 or 100 terabyte of hard disk and I have 500 GB of RAM and I'm having, let us say, 100 processors I'm having in a computer. So this is the configuration. Here I have installed Oracle. Same Oracle I have installed here. Now tell me, what is the data I can store? I can store up to 100 terabytes. If we're talking about 6 terabytes per annum, 100 years, 10 years means 60 terabytes. I can use this system at least for 10, 20 years. I can store large amount of data. So this is Oracle data warehouse. Clear? So, data warehouse means what you need to understand. It is the same SQL software you need to install, but only thing is that you need to have large hardware. Clear? What kind of a data warehousing is going to be storing? It is going to be storing structured data, business data. That means the data which is there in the rows and columns means a table data. So till 1960s to 1990s, only companies are talking about data warehousing, and inside that they're able to perform data analytics also. We be able to create lot of reports, lot of visualization tools being developed, and they were able to create lot of visualization. They were analyzing the data, completely structured data till this era. 1960s to I'm talking about 1990s. But early 2000, what has happened? Internet is released and hardware software cost is got reduced, cheaper software, cheaper hardware is introduced, and internet network is released, and many people started, internet and social media got also introduced. So slowly we are getting not only structured data, we were talking about semi-structured data, we were talking about unstructured data also got created or added. Social media, Orkut released in the year 2002 and 2003. Social media, Twitter, lot of data or lot of IoT, lot of sensors data, and social media data, getting added uh, to the in IT, but IT industry does not have any proper storage device. Okay, so till 1990s, IT industry is only talking about data warehousing and the SQL, softwares. But in year 2000, this was a story. 2003, Google company talking about I need to have one solution. Okay, so big amount of data we are getting, large amount of data we are getting. We need to have one solution. Okay, for this data, they have given a special name to this kind of a data. It is very bigger data we are getting, not only structured, semi-structured, unstructured data, we are also getting a big volume of data, right? So they have given a special name, petabyte, zettabyte, yottabyte of data. We are talking about earlier data warehouse can target only terabytes of data, but here we are talking of petabyte of data, zettabyte of data. 1,000 terabytes into is equivalent to 1 petabyte. 1,000 petabyte into 1 zettabyte. This kind of a data is called as a very unlimited data. So special name given by the IT industry, big data. So one is size. Second one is not only structured, semi-structured, unstructured data. So how do you deal this kind of a data? So 2003, Google company released a paper on the unlimited data, big data, and how do you store the data? How do you do some kind of a data analytics? This on this kind of a data, they have released a paper in year 2006. A Apache software foundation company released a software called Hadoop. Clear? So Hadoop is a single solution. It may be structured data, it may be unstructured data, it may be semi-structured data. Structured means a table data. Unstructured means images, audio files, video files, chat messages, state twitters, your hospital images, X-rays, scanner documents. All this can be stored. So they invented a software called Hadoop in year 2006. So that was a story. Clear? So, but Hadoop is built or developed using a Java language. Clear? So Java means people wanted to learn Java to work with the big data. So that is what is the biggest issue that time I was talking about. So three V's: structured data, semi-structured data, variety of data, volume of data. So petabyte, zettabyte, yottabyte of data, volume, and the speed in which the data is coming, velocity, variety, volume, variety, called a three V's. Big data means it is containing this kind of a things, right? So how do you store? So I cannot have different solution. For the structured data, use this. For unstructured data, use this. For audio data, you should use this. So I cannot give that kind of a different solutions. Google came up with a single solution approach. They have released the big data concept. What is the problem they have understood? What is the solution also they have stated clearly based on their paper. The Apache Software Foundation company released a Hadoop software where you can store any kind of a data, you can process or you can compute any kind of a data. This is one solution. But the problem is Java you need to learn. Second issue is that you have to store the data. Hadoop is going to be storing the data in hard disk. Hard disk means reading the data, writing the data will be slow. Slow means what? In terms of data reading or data writing, both of them are slow. Clear? So lot of coding you need to write. So many people said Hadoop is also beautiful tool, big data, fine. But the Hadoop tool was not very good. So it is completely, hated. So Java you need to learn. hard disk and slow lot of coding to overcome this in year 2012, I think. Year 2012. So we got a one more, tool got introduced. So that is what is called Spark and Scala. Okay, so this has got introduced, I think 2011 or 2012. I'm not sure about it. So where Java is not there, they have included a new language called Scala, because Java is a OOPS-oriented language, object-oriented language, which is meant for web development. Which is meant for web development. So when you have so much of a data, on the data, what kind of a use cases you will have? On any data, whether it is Excel data, SQL data, data warehousing data, or whether it is a big data. What kind of a use cases normally we have? Two types of use cases. One is called artificial intelligence, or one is called data analytics, called as a BA. Right? I have so much of a data. So if I store the data in the big data Hadoop, so after that I need to analyze the data. Right? Storing and retrieving, storing and processing, I need to use only Java, but Java is not a good for the data analytics or for the AI to implement further. Right. So end of the day, when you have any kind of a data, we are going to be doing, the data can be anywhere. Data can be either in Excel, or data can be in SQL, data can be in data warehousing, data can be Hadoop. End of the day, we are going to be using AI and BA. This is the use case for your data today. Right? AI means artificial intelligence. BA means data analytics. Data analytics is called as BA. Right? End of the day, data may be coming from Excel or from SQL or from data warehousing or from the Hadoop system. But end of the day, you have to perform this kind of a things later, right? But Java is not so good to perform data analytics on the data. Clear? So you need to have some good tool that can perform data analytics, or it is going to be suitable for the AI applications. Clear? Simply AI and BI means that study of the data. So machine learning means what? Understanding of the data or studying the data more depth. And end of the day, that is what you got to understand, right? So Java is not suitable for AI and BI. Scala is suitable. And Scala is also less coding. That is the beauty about it. Not heavy much heavy coding. This is the beauty. Spark and Scala introduced. So it is a powerful tool which is going to be storing the data in the hard disk. But this guy is able to store all the data into the RAM of your computer. That means memory. Because of memory, this is becoming very, very faster. How many times? It is a 30 times faster than the Hadoop system. Clear? So it is released, Hadoop is released in the year 2007, right? So afterwards, Spark and Scala got released, and Scala is the language. Now here, Hadoop is have a language called Java. Then they have given some more languages like Hive. They have given some more language called Pig. If you're not able to learn Java, at least you learn Hive and Pig. A lot of other languages got introduced, but these are not very good. So end of the day, you need to perform lagging and slow, and this is the issue. But today, Spark got introduced with a Scala language, less coding, memory 10 times faster, and lot of coding you have to write. Now you say no coding or the low coding. No coding or low coding, you can say. Okay, low coding, that is the beauty, and it is very, very easy to write the language, and it is suitable for AI and BA. This language is suitable for BA. BA means business intelligence. It is also called as a data analytics. Clear? So AI means artificial intelligence. It is also called as a machine learning. So the Scala is beautifully developed. Clear? And if you still further automated, the easiest language, Python also you can implement, right? Python also you can implement. So people wanted to implement a programming means you can also write Python coding. SQL is also you can add, because data means SQL compulsory. It will be there. Clear? So people were happy about this, but later in 2013, in 2013, the story does not end. So they have again refined it. There were a lot of some kind of an issues. Even though it is a faster, it is suitable for A and B applications. It can take Python language, SQL, PySpark, Python, PI, and Spark and Scala. You can use PySpark language is one more language got introduced. So a lot of things got added here. But even then, there are some couple of issues, and they have done some more development. And in 2013, uh, there is a software called Data Bricks got released. Okay, so Data Bricks is means it is nothing but your Spark and Scala. Spark and Scala is nothing but your Hadoop system. Hadoop is going to be used for your big data solutions. What kind of a data you can store? You can store structured data, unstructured data, semi-structured data. Now you can understand what is a data warehousing and what is a big data. Data warehousing only can store, it is going to be having SQL software, it can only store structured data, and it can only store up to terabytes of data. Clear? So that is the data warehousing technology. So here, when you have so much of a data, petabyte, zettabyte, or even though you have a structured data, data warehousing will fail. We are going to be implementing Hadoop, right? So Hadoop is not there today. We are going to be creating a Spark and a Scala. Clear? So that is what we need to understand. So now today, instead of using the Spark and the Scala, so people are implementing data bricks. Clear? So we advised Azure Data Bricks when you need a generic and scalable solution that can be applied for the multiple data source and use cases. You have coding experience and want to learn Apache Spark, and it is for the big data solution. Clear? So I'll talk about ADF very soon. So this is a big data solution. Data Bricks is invented by Dr. Ali. So who's that guy? This is the guy. So who's the founder of Databricks? Godse, Ali. Ali Godse is the president or CEO or the founder of the Databricks. Is a co-founder along with this guy. Few more guys have invented this. End of the day, what is that? A leader in data and AI. He pioneered the data intelligence platform built on the Lakehouse architecture. Blah blah blah. End of the day, when there is a data, what is the use case for the data today? So today, data, when you have it, one use case is either AI, one more use case is one more BA. BA means data analytics, right? Data analytics means what? Understanding past. But what is AI or ML means? It is predictions, right? Planning for the future predictions. So here we're going to be having a lot of algorithms. So machine learning algorithms. So machine learning algorithms are good when you have a limited data. Machine learning is good when you have a limited data, but when you have a large amount of data, petabyte, zettabyte, so banking data, insurance data is not a very large data when you compare with your social media data, right? So insurance data, ML is good, but when you have more and more data, that is where even machine learning is going to be failing. So that is when you have a deep learning is concept evolved recently. Clear? Machine learning can work with the some kind of a data, some portion of the data. When you have a large amount of data, for example social media data, when you have it, banking data, insurance data, you should not think that it is a big data. Right? So you have much more data. That too, the data is more unstructured data, semi-structured data. That is when machine learning will fail. That is when deep learning will start. Deep learning will start. So end of them AI, ML, DL, it stands for the predictions. You will have data. With the data, see, normally any machine is not intelligent by default, right? So I'm not intelligent by default, but normally when I study something, I'll become an intelligent. So any machine, any computer, it is not intelligent by default. What do you mean by artificial intelligence? Machine is not intelligent by default. You have to give some steps or some programming or some model you do. With that help of that thing, it will become an intelligent. That's it. So you do 100 things to the system. I don't know what you do. You give some X algorithm, you give some Y algorithm, because machines by default not intelligent. But what is artificial intelligence means? You make the machine intelligent. How do you do that? There are 1,000 ways to do that. So the 1,000 ways are nothing but your artificial intelligence or machine learning. Clear? Make the machine intelligent is called as artificial intelligence, because machines or computers or your laptops not intelligent. You do something. There are 100 ways you can use. You will be able to make the machine intelligent. But to make the machine intelligent, what machine needs? It needs a data. Clear? It needs a data. So because of the data, because of so much of data is available today, artificial intelligence is working today. Remember, artificial intelligence is started not, it is started in early 1960, 1860s, not now. But why artificial intelligence is not so popular? Because it does not have so much of a data. That is the problem. So IT industry started 1920, 1960, 70. Now you have so much of data. So again, so since you have so much of a data, artificial intelligence algorithms can work. Clear? So make the machines intelligent by doing 100 things. I don't know what you do, but you will be able to give something so that machine will be intelligent. But what it will take your data. So data is your input to the artificial intelligence or machine learning or a deep learning. So if you wanted to run your applications today, normal Excel, I have data in Excel, can I run A and ML? You can run, but not beautiful things. You cannot do that. Even SQL, you can run A and B. Even data warehouse also you can run A and B. But more than this, so if you keep the data in the big data, that means Hadoop or Spark and Scala Databricks when stored, you will be able to perform very good AI applications or BI applications. So more people are now towards big data. So big data is started off with Hadoop. After that, it is started off with what? Spark and Scala. Now this guy is done some more developments to the Spark and Scala. He has introduced Databricks. If somebody asks you what is a Databricks, is it a Microsoft tool? No, 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 no. Is it an Amazon tool? No, 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 no. Databricks is one more third-party company. They have released Databricks. Azure is using this inside Azure. Clear? So I'm using this component inside Azure. So it will become a Azure Databricks. If I use this Databricks in my AWS, it will become Amazon Web Services Databricks. If I use as a service in the GCP, Google Cloud, it will become Google Cloud Databricks. What is a Databricks? To store or to handle with the large amount of data, we are going to use a Databricks. It is nothing but a one more layer is attached to your applications, right? So in India, we are going to be booking train tickets, right? So train ticket, normally what we can do? I wanted to book a train ticket. I can go and book online. That is one thing. Or I can go to a reservation counter. I can go to office, reservation counter. I can get the train ticket, right? Or I can book online. Or I will be able to go to agent or a broker. I will ask them to book it. So train ticket I need it, I can book online. I can go to the counter and do it. I will be able to, go to the agent. So if online is there, counter is there, but why agent is there? Because agent will take care of a lot of other things. Clear? So online, you're not sure whether you can get it or not. Even when you go to counter, you're not sure you can get it or not. But when you go to agent, you're 100% sure that I will be able to get a train ticket, right? So like that, even though you have a Hadoop, you have a Spark, and you have Databricks. Databricks is more, like just like agent. It can 100% do a lot of, good things are available here. Or you can go to Spark and create a Spark and store the data. Or I don't want to go to Spark. Still, you can go to Hadoop and store the data. But a lot of issues. But Hadoop going to store the data in the hard disk, and slow Java coding or high Warpig you need to learn. And the Spark is the modern tool for the big data concept, and which is going to be giving you new language called Spark and Scala, going to be storing the data in the RAM 30 times faster. And Databricks is completely refined and created on top of the data bricks. It is a big data solution. So guys, did you clear? So who's the founder? So one of the founder is this guy. So am I clear? So what is Azure Data Bricks? Azure first party service tightly integrated with related Azure services and support. So Databricks is not a Microsoft Azure, software. Analytics and for most, complete and recent, blah, blah, blah. So data, the last point you can understand, reliable data engineering for the large scale and data processing for the batch and streaming workloads. Now, we are talking about data, right? We are talking about big data. Big data means what kind of a data you may get it. So as we know, we can get the structured data, we can get unstructured data, we can get semi-structured data. One more thing you need to understand. So the data can be unstructured, semi-structured, that is fine. You may be getting live data. Live data means streaming data. Continuously, the data is getting streaming data. Streaming data. Okay. And you may be getting batch data. Batch data means historical data, old data, Purana data, historical data. So means large, big amount of petabyte, large data. Clear? So your Hadoop or your Spark, Scala and Spark I'm talking about, or I'm going to be talking about your, data bricks. Okay, data bricks, which can take your structured data, unstructured data, and semi-structured data. Along with that, it is also can take streaming data, batch data, batch data again, structured data, unstructured data, semi-structured data. That means historical data, large data. Batch data means old data. For example, a railway last 20, 30 years of data have how many people have, booked the reservations. Last 20, 30 years of data have it. Last 20, 30 years of hospital data have it. That is a batch data, historical data, large data. We are calling this as a OLAP data, online analytical processing data, means large amount of historical data, this kind of a data. And timestamp data or time series data also you can have. Okay, time series data or timestamp data. What is the meaning of this? I wanted to know over the period one employee salary in year 2020, he was getting 12,000 salary, and year 2021 he was getting, let us say, 19,000 salary over the period. Now after that, next year he did not get anything. Next year also the salary is the same. Next year, he got a 25,000 salary. Over the period, one guy salary. So this is what is called a time series data. It is also called as a slowly changing dimension data in the data warehousing applications. We'll be talking about later. Time series data or time stamp data we're talking about. Over the period, how is the an employee's salary if you wanted to analyze. So all these things you will be able to analyze. Clear? So end of the day, not only this, we can do a lot of things. We can understand the patterns, we can understand the trends, we can run many machine learning algorithms. So live stream, lot of things we will be able to do on this. Clear? So that is what is called large scale data processing for the batch operations. Batch means what you need to understand: historical data, large data. Streaming data means every minute you're going to be getting the data, whether forecast data or live, Sensex data, share market data. Every 1 hour the data is going to change, whether the data, all the data, whether forecasting systems or you have live Sensex data, share market data, blah, blah, blah. Clear? So this is very, very good, so that you will be able to store the data in the Azure Data Bricks. Azure Data Bricks is the good solution for the big data if you wanted to store and deal with the data. Clear? Now, so If you think about a company called Amazon company or think about any company, so if you say, you go to Amazon company and you ask them, hey, Amazon, you give me the data. I wanted to uh, create a lot of insights on your data, or I wanted to create a lot of AI and BA work on the data. When you ask the Amazon company will say, hey, I don't have the data in a single location, right? I have some data in India. I have some data in Dubai. They'll say, I have data in India. I have data in Dubai. I have data in, let us say, Dublin. I have data in, let us say, Singapore. I have data in US, UK. So like that they will say. So they will say, we don't have the data in a single software. In some cases, I have data in SAP. In some places, I have data in .NET. In some places, SQL Server. Some places, Oracle. Some places, I have text files, blah, blah, blah. And when you see the accuracy of the data may not be cleaned data. Sometimes a lot of duplicates are there, lot of misvalues are there, low accuracy, medium level accuracy, or data is very, very high accuracy of the data, right? So the size of the data, when you see, they have some places medium data, MBs, gigabytes of data, some places medium list, or maybe gigabytes and terabytes of data. High and large volume of data means petabyte, zettabyte of data, they will be able to get it. Now, what we need to do, we need to analyze the data. Means earlier days, I was talking about 1960s to 1960s to still 1990s. So how people were using, clear? In the IT, you are getting the data from anywhere. You will be able to go to your SAP system, .NET system, this system, that system. You will be able to extract the data. You will be able to perform. Maybe SAP, maybe in there in Dubai, it may be Java computer which is running, maybe in India, this may be Excel sheet, maybe there in, let us say, in call center, but all this data belong to Amazon company data. So what we used to do, we need to extract the data. Transform means you need to clean the data and you need to read the data. So Microsoft has given a tool called SSIS. So SQL Server integration services or third-party tools like Informatica, all of them are called, uh, all of them are called on-premises tools. You will be able to get the data. You will be able to store the data. All this data, initially it was more structured data only. So we were able to store all the data into the data warehousing. So data warehousing means I told you large hardware and SQL is installed. Clear? So this was a story 1960s and in early 2000 also. So you will be able to get the data from different machines and will be able to get the data, keep the data. SSIS Informatica got released in year 2000. SSIS got released in year 2005. Informatica it is there, I think 1990s onwards it is there. And it is there 2005. It is 1990s to 2000, I think it is there. Informatica data stage, lot of tools are there. Get the data from many machines and transform the data means clean the data. All the data belong to Amazon company. What I do, I can combine the data because it is completely sales data. Where will I keep the data? I will be able to keep the data in the data warehousing because it is a structured data. You create a data warehouse, you load the data every 6 months, every 1 year, you have the data. On top of that, what normally we were creating, we create a lot of reports. Okay. We create a lot of visualization and report. And this is what is called a data analytics or business intelligence. This was a story. So now year 2005 on-premises tools were happening. Now cloud is started, Azure is started from 2003. That is Amazon Web Services. Amazon AWS started in this time. Then Azure is started in 2010. So you have a lot of cloud machines are started coming in. So the SSIS Informatica cannot talk to Azure machine or AWS machine or a Google cloud platform. It cannot get the data. If the company is today, we are in 2024. I have a cloud machine. If some company says I am not having data not only in the on-premises servers, so I have data in one of the cloud I'm storing. For example, they say I'm using AWS. There's a cloud machine. Inside the cloud, I have a database called Oracle database, a SQL database. I have given what is a cloud. I have clearly, explained yesterday. Please watch that. They have told I have my data today. You take the cloud data and try to store in data warehousing. So SSIS will fail, Informatica will fail. Why? SSIS is released before cloud. So Azure is released in year 2010, GCP 2009, right? But SSIS is released, Informatica is released 1990s to early 2000. So these existing on-premises ETL tools cannot go to cloud and get the data because these were developed early to the cloud platforms. Clear? Cloud is released 2003, 4, 5, but in the market 2010 onwards, 2009, 2010 onwards became so popular. So I don't know how to get the data. So SSIS Informatica is failing. So what Microsoft has done, Microsoft told, so I will give you a software that is ETL software only. That is what is it is a cloud software called Azure Data Factory. This software is released, even though Azure is released in 2010, ADF is released in 2015. They said it is my ETL software. So what we can do? So if you have a data in a cloud, so you will be able to extract the data from the cloud. You will be able to dump the data here. Clear? So SSIS can work or on Informatica data stage. A lot of on-premises ETL tools were working only to get the data from the on-premises servers, on-premises Java, on-premises SAP, on-premises Excel, on-premises SQL. You can get the data. But somebody says, I have the data today. I'm in 2024. I'm in June month. I have data here. Can you get the data? SSIS will fail. So that is where we are using ADF. Clear? We're using ADF, getting the data, we are loading the data into this. Now, if you have so much of a data, if you have up to terabytes of data, you will be able to load the data into this. But if you have bigger data, if you have a bigger data, what I have to do? If you have a bigger data, you will be able to load them into Hadoop or you need to load them into Data Bricks. You can load them into Hadoop or you can load them into Spark and Scala, right? Or you can load them into Data Bricks. Clear? So that is what ADF can be done. ADF can be used. We can create one Hadoop or Spark and Scala, or you can create a big data architecture. You will be able to extract the data, much more data. If it is a limited data, you will be able to store in the data warehousing. Otherwise, forget about it. You will be able to load your data to your Hadoop or a Spark and Scala or a data bricks. So you can store very, very big amount of data. So you will get the data from many sources. You are going to be performing either ETL steps. ETL means what? Extracting the data. Transformation means cleaning the data, loading the data. But the problem is, I'm talking about a petabyte of data. I'm talking about a zettabyte of data, large amount of data I'm getting. So I cannot perform ETL operations. What do you mean by ELT? I'm going to be talking about extracting the data. Simply you load the data. Where will I load the data? To the big data. So I have one more Spark is there, one more Hadoop is there, one more cluster is there, where I will be able to load the data. So when you have a large amount of data, ADF cannot do the cleaning work because when you have so much of a data, for example, I have one 25 kg of rice bag. I can, me and my mother put together, they can clean the rice bag, right? But if I have 100 lorries rice bags, I'm getting it. Do you think that my mother and brother can clean the data? So what normally you do? Will you clean and data and load it? No, no, no. When the rice bags comes, 1,000 lorries are coming. There is a big go down. I'm talking about Food Corporation of India. You think that is a Hadoop? Clear? Food Corporation of India is a bigger godown. I'm talking about a very big godown. You're going to be storing large amount of rice bags in that godown. That is ready. Who's going to be getting the data? ETL. ETL means what? Lorry. Lorry will go to the different cities and from the farmers, the government of India buying the rice. Sources are different farmers in all over the India. So lorries will go collect the big amount of rice from there. So do you think that it is a cleaned rice? No, 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 no. But will you be cleaning the rice? You will be cleaning the rice later. But what you do? You get the rice bags, load it into the lorry. Lorry will be your ELT. Extract the data, extract the rice bags, load the data warehouse or load into the godowns completely. You cannot clean the data because to clean one driver, one lorry owner, or 100 laborers are not enough. You need to have thousands of labor. You need to have it clear. So extracting the data, loading the data will be done first. So transformation will not be happening in the ADF level. ADF is simply ELT tool. Why? It is going to load large amount of data to the godown. The godown is, I'm talking about either Hadoop or the Spark and Scala. And here I have so much of a data, right? So later, if I'm going to be using the rice later, so I have thousands of rice bags are available. So before using, I don't, take all the rice at a time, right? I may use, 10 bags of rice. What I do, I get the 10 bags of the rice, I clean the rice, I cook for a function, or I will be able to deliver it to someone else. So later, you're going to be taking 10 rice bags, 5 rice bags, you're cleaning and using. That is what is called ELT, extracting the data, you load the data. Transform means cleaning the rice bags when before you use it. So tomorrow there is a function. Somebody is asking, I need a 10 rice bags. What you do? You go to your godown, get only 10 bags or 20 bags or 100 bags, you clean them, you give it to them. So then they will be able to use that. So what if tomorrow I wanted to perform data analytics or BI or AI on this data? What I do, whatever be the data I need it, that data I will take it, I will transform it, then I will send it to BI or AI. I can create lot of A and ML applications. Now, this is what you got to understand. So that is what is called ETL and ELT. That is what is called ADF and ADB. Clear? ADB, where you can store large amount of data, and uh, it is not a single machine. That is also need to understand. Data warehouse is also a single machine. You can get the data from multiple machines, and all the data you will be able to store in a single machine. You're going to be storing the data and creating, processing the data and creating reports on the single machine. Data warehousing is a single machine. You get all decentralized data. You're going to be centralizing it here. But now, big data Hadoop. I'll take 5 more minutes, guys. Big data Hadoop, Spark, Data Bricks. It is not a single machine. It is multiple machines. Try to understand. So earlier, I'm talking about you get the data from multiple machines, right? You will be able to perform ETL operations. You will be able to store the data into the data warehousing. This was a story in 1990s up to early 2000. You are going to be decentralized data. You are going to be centralizing because it is a terabytes of data. You can accommodate it. But later, I'm going to be getting a big data, very big amount of data. I'm going to be using ADF or some other tool. I'm going to be storing in the Hadoop. So Hadoop or Spark? Hadoop or Spark, Scala or Data Bricks? Do you think that it is a Data Bricks I'm talking about? Do you think that it is a single machine? It is a single computer only. This is a single computer with, let us say, 100 terabyte of hard disk. Let us say 500 GB of RAM. And this may be some 100 processors are running. That is fine. But now I am talking about, can I get a bigger machine? Because I'm talking about if I get 1,000 petabyte of data, if I get 1,000 zettabyte of data, no, will I get this kind of a hardware? You will not, right? So data hardware is today up to available 100, 200, terabytes. Bigger than that, hardware is not available today. I will give you a simple example. In my in my home, I have a washing machine. We are 4 to 6 people. I can use one washing machine, 6 kg washing machine. My brother family also included. We are 10 people. So one washing machine is not enough. So what I do, I may buy a bigger washing machine. Instead of 6 kg, I will buy 10 kg washing machine. That is tomorrow. We may get some more relatives and friends. They are there. So what we do, same washing machine, 10 kg. We are going to be using multiple times. So morning one round, afternoon one round, evening one more round, so that we are able to accommodate. Let us come to one more example. You have a hostel. How many people are there in the hostel? 200 people. Now, do you think that can you get a very big washing machine? 6 kg is there in the uh, market. You can go buy 6 kg washing machine or 10 kg washing machine. You can also buy. This is bigger. So maximum you ask, they told that, sir, we can give you at least some 15 kg. That is the maximum size we can offer you. Okay. But now we are talking about 200 people, clothes we need to wash it. So, can you get very big washing machine? So, what you do? You will not be able to get a bigger washing machine because we're talking about not only 200 people today. Tomorrow, the hostel size may increase to 10,000 people, 20,000 people in the hostel. You cannot get a bigger washing machine. What you do? You buy multiple washing machines. So, you cannot store the data. You buy multiple machines here, not only single machine. You cannot store the data in a single data warehousing is a single centralized architecture, right? When you have so much of a data, you will not be able to store them in a single machine. You will buy many machines. Let us say you buy some 100 computers. 100 computers you buy. So each computer capacity is 100 terabyte, 50 terabyte, like that. Now, when you get the 1,000 petabyte of data, you will be able to store it here. So this is what is called a cluster. This is what is called a cluster. So Hadoop is not a single machine. Spark and Scala is not a single machine. It is a cluster with thousands of machine. Cluster with thousands of machine. So data warehousing is going to be storing the data centrally, but Hadoop is not going to store the data in centrally. It is a decentralized architecture. Remember that. So Hadoop is not a single machine. Spark is not a single machine. Data Bricks is not going to be working on a single machine. So if you have 2,000 people in the hostel, what you need to do? You have to buy at least a 20, 30 washing machines. What you do? You're going to be distributing the workloads, right? So what you do, you say, hey, you 5 people use this washing machine. Hey, another 5 people use the washing machine. Distribute, and they will be able to accommodate. And there is a laundry man is going to be there. He is going to be maintaining all the washing machines, right? So the remaining work will be done by the washing machines only. So here you have one master guy, and these are called slaves. One master guy, one master machine is there, or a master node, we will say. This guy is going to be getting so much of a data. Some data will be keeping it here, some data will be keeping it here, like that. He will be able to distribute the data. So that guy is a laundry man. If you give 1,000 shirts, laundry man will be distributing. So what all you need to distribute? Not only the shirts, but also the washing powder, water supply, power, everything you need to supply. So when you put large amount of data, all the data will not go to one computer. So your data, for example, you load 100 GB of data, 100 GB of data, let us say, some 30 GB of data will be here, 30 GB of data will be there, remaining 40 GB of data will be there. It is going to be distributed because it is a cluster. Clear? Now, who's going to be distributing this machine? So, cluster is going to be having one main server, main computer, and the three machines are going to be maintained. If there is a problem, for example, you have this machine is not working. Is there any problem? No problem. Whatever be the data that you have given, the same data you have to shift it here so that you will be able to run this clearly. This machine is working. This machine is working. If there is a problem with the machine, the next machine you can use it. But since you have a one machine, if this machine is failing, entire data warehouse will fail. So that is one more biggest disadvantage in the centralized architecture. And Hadoop is a decentralized architecture. Hadoop, Spark, Scala, Databricks is not a single machine because we are talking about large amount of data. Single machine cannot store, cannot process. Clear? I'm talking about I have 1,000 rice bags need to be cleaned. One labor cannot do that, right? So now all the all the data, petabyte of data, I'm putting in my cluster. My cluster can clean the data very, very clear because I will not give all the data to one machine. I will give it to some portion to this machine, some portion to this machine. So if I done only transformation job, data cleaning job, where in the cluster level, that is the data bricks level or Spark level. Clear? So Databricks, what it does, now it has the data, it has many machines. Now I'll say, hey Databricks, you transform the data, you clean the data. Now Databricks can neatly clean the data. Why? Because Databricks is not going to be having a single machine. It is a cluster of machines. Even the one machine is failing, it does not matter. It is going to be using some other machines. You need not have very high-fi servers. So, if you have a hostel, do you think that everything will be a very hi-fi washing machine? No, you may have 6 kg washing machine, you may have a 10 kg washing machine, you may have a 20 kg washing machine, you may have 7 kg washing machine. So any hardware can be used as a slave. You may have normal my laptop, I can give as in the cluster. So maybe small configuration in a computer. Maybe one computer with 100 terabyte of hard disk. So this kind of a hardware is called as a commodity hardware. Commodity means cheaper hardware. You need not have the very costly hardwares everywhere. You can buy small machines, 100 machines you can buy. You will be able to do it, right? There's no problem at all. You need not have bigger computers to do that. So smaller computers, you can buy many so that you will be able to perform these operations. So cluster. So who's going to be giving you cluster? Either you can buy 100 machines, you need to install Spark or Scala Databricks software in that, you have to run, that is on-premises cluster, on-premises Databricks. But now who's going to be giving you Azure? When you go to Azure company, when you say, hey Azure, I need Azure Databricks, so it will ask you how many machines you need, how many master nodes you need, how many slaves you need. I need one master, I need 100 slaves. I need one master, I need 8 slaves. So I need one master, I need 1,000 slaves. So Azure is going to be giving you for rental. So rental machines are called as a cloud. So Azure Databricks means, so Databricks software will be installed. That means behind the scenes, Spark and Scala, and the Spark and Scala behind Hadoop is going to be used. Clear? End of the day, Hadoop is there. And on top of that, Spark is going to be working. On top of the Databricks is going to be working. So when you say, I need a Databricks cluster, means Azure is going to be giving you multiple computers. Clear? For that, you need to pay the rental amount. Clear? So that is what you need to understand. What is a Azure Databricks means. Did you understand clearly, guys? I'll stop it. Are you clear? Or am I clear? So that is what is the point today. So when you have the data, you can perform deep learning, streaming, data warehousing, Power BI reports, everything you will be able to learn. You can also get the data from many places, and you will be able to work with this. So tomorrow we'll talk about some more things. Data warehouse means only structured data you can store it. Unstructured data you will not be able to store in the data warehousing. So when you have once you have the data, end of the day you will be able to perform AIBA applications. Clear? Azure Data Bricks means a cluster is going to be created on the Azure platform, and a data bricks is going to be installed there. Every month bill will get generated, and you need to pay for this. That's it. Okay, na? So cloud means, as I told you, rental platform. So on premises, Spark, Scala, or Databricks also you can maintain, but that is a big headache. I don't want to maintain buying a server, installing the software, so that will be of no use. Clear? So we may have Databricks inside Azure, we may have Databricks inside Google Cloud, or we can have Databricks inside our AWS. Chalo, guys. So we'll continue from tomorrow. And today, you will be able to get the payment links. And if you're interested, you can make the payment and continue. You can join ADF and ADB. Now, ADB is going to be happening for 20 days, 25 days. Once that is over, ADF is going to be starting. So you can talk to my team. So these are the numbers. They will be able to give you combo offer. You can join data engineering course. Clear? They'll give you single fee, or you can also pay, course by course. That is also fine. So when you take a combo offer, you will get more discount. When you buy a course by course, you will be paying more. So talk to them. They will be able to send you the data, the payment data within 1 hour. If you don't get it, so you can just call them. If they don't respond, I have given my number also, right? My number is 991991. My number is in the last one. It is going to be your 5. Okay. You can also ask me, sir, I have attended your data engineering course. So I would like to have the payment details. You can also make installments. So from tomorrow, the meeting ID will change. The people, who paid, they will be able to get the new meeting link. Same time, you can join from tomorrow, guys. Any questions?
Hello, sir. So is this related to fabrics also, like fabrics, Microsoft fabrics?
Because Fabric is similar to your Snowflake. That is the data warehousing. Okay.
Okay.
That is not covered in this. Fabric is something different. It is ready-made data warehousing we had, right? Snowflake is more popular. So Fabric is similar to that. But Data Bricks is something big data concept. Okay, na?
Okay, sir.
Chal. Very good. Anything else? Guys, did you like that demo? Nachinda? Did you like it? Say yes, no.
Yes, sir.